In a namespace, each partition has an associated list that defines the order in which partition replicas are assigned to nodes. This succession list can be computed by all nodes at any point to identify replica distribution throughout the cluster. As clusters form and change, by default, Aerospike uses the uniform balance algorithm for even distribution of data throughout the cluster. As nodes join or leave, uniform balance may change the order of succession to maintain the balance of data. Rack awareness can impact distribution of replica partitions by forcing non-master partition replicas to be stored on different hardware failure groups. This ensures that all replicas, including the master, exist on separate racks. Let's explore the succession list for a single partition with replication factor 2 as changes to the cluster occur. For the sake of simplicity, we'll assume that uniform balance is not affecting partition distribution and we're not using rack aware. In the cluster, node A owns the master copy of partition 3467. Node B owns a replica copy of the partition, and nodes C and D do not contain any records for the partition. This is our steady state. The first change occurs when node A leaves the cluster. This could be due to maintenance or the node may have gone down. With node A gone, node B takes ownership of the master copy, since it contains a replica of all the partition's records. Node C takes ownership of the partition replica, but with no records. Node C immediately starts receiving replica writes from node B, and depending on the configuration, node C may also start to receive fill migrations, filling a node that's not normally a replica. These migrations can be suppressed for a specified duration by defining a migrate fill delay, if the situation calls for it. The succession list is based on node ID, so if a node returns with a different ID, maybe due to hardware changes, the succession list could change. When node A returns to the cluster with the same node ID, it doesn't have a full copy of the data as existing records could have been updated or new records could have been created. Node A takes ownership of the replica copy, and node C is no longer considered a replica, but retains data until there are 2 full copies for this partition. Since node A originally owned a copy of the partition, it begins to receive both new replica writes and delta migrations from node B. Before migrations for the partition complete, node B leaves the cluster. Due to the order of the succession list, node A becomes the master copy and C becomes the replica copy. Both nodes A and C are subset partitions, as neither owns a full copy of the data. But between the two of them, they do contain all the records and updates for the partition. When a transaction for a record on the partition occurs, a process called duplicate resolution will be used to determine which of the records, between nodes A and C, is the correct copy. When node B returns to the cluster, the nodes are marked as subset until all migrations have finished. Once each node has the latest version of the records, our steady state is restored.